Okay, so we're going to have a look at another question from university linearity. So we're told to let capital X equal X, which equals x1, x2, x3 included in R3. Now we're given the condition x1 plus x2 plus x3 is equal to 2, and we are asked, is capital X a subspace of R3? Okay, so our three conditions. We need 1, a 0 vector. We need 2, closure, so closed under addition. And then we need 3, closed under scalar multiplication. So let's do one of these at a time. Let's start with 0 vector. And when you're doing these, you only need to show that 1 is not true for it to not be a subset, right? So if you're in an exam and you have this kind of question, the minute you've shown that it either doesn't contain a 0 vector, isn't closed under addition, or isn't closed under scalar multiplication, the question's finished, right? It's failed to satisfy the conditions. We're going to have a look at all of them. So if we have a look, we're told x1 plus x2 plus x3 is equal to 2. So the 0 vector is 0, 0, 0. This would imply that 0 plus 0 plus 0 is equal to 2. This is false. So immediately we're off to a good start. It fails to contain a 0 vector. So no. We know the answer straight away. No. Cap X is not a subspace of R3. And we could conclude that, but we're actually going to have a look at addition and scalar multiplication as well. So we're able to show this is not a subspace by showing there was no 0 vector. Let's look at closure under addition. So let's set up two vectors, u, which we'll say is alpha 1, alpha 2, alpha 3, and v, which is beta 1, v is beta 1, beta 2, beta 3. The sum of these two vectors, u plus v, gives us a new vector, which is alpha 1 plus beta 1, alpha 2 plus beta 2, alpha 3 plus beta 3. Now it needs to be the case that the sum of these terms is equal to 2, because that's the condition. So this implies that alpha 1 plus beta 1 plus alpha 2 plus beta 2 plus alpha 3 plus beta 3 has to be equal to 2, but this is equal to alpha 1 plus alpha 2 plus alpha 3 plus beta 1 plus beta 2 plus beta 3. And we know each of these individually is 2. This is 2, this is 2. The sum of these two things is apparently equal to 2. No, this is false. So not only does it not contain a 0 vector, it fails the test for closure under addition. We can also have a look at closure under scalar multiplication. So we can say we have some vector u, which we'll call alpha 1, alpha 2, alpha 3, and then we'll have some constant. We might call this c. So this implies that c times u is equal to c alpha 1, c alpha 2, c alpha 3. And we need the sum of these terms to be equal to 2. That's the condition. So we get c times alpha 1 plus c times alpha 2 plus c times alpha 3 has to be equal to 2. Well, if we factor c out, we get c times alpha 1 plus alpha 2 times alpha 3 is equal to 2, but we know this is 2. So now we get the expression that c times 2 is equal to 2. This is only true if c equals 1. And because it's not true for all values of c, it fails the test for closure under scalar multiplication. So failed 0, failed addition, failed scalar multiplication. It didn't need to fail all three of them. It could have passed two of them and failed only one of them, and it still would not have been a subspace of R3. But you can show this numerous different ways. In this video, we demonstrated all of them. If you're in an exam, you only need to demonstrate one of them. That is sufficient evidence for it to not be a subspace.